Hi, today we're going to go over the build of an Eggtimer ION Wi-Fi enabled altimeter. It is a flight computer that basically gives you flight data. It doesn't have any deployment channels, so it's pretty simple. It builds out pretty small, so you can fit it in a smaller rocket. It works really well on its own. However, if you pair it up with a telemetry module, you can get real-time data using the Eggtimer LCD receiver about your flight. So it's pretty cool. It's a pretty cool altimeter and pretty easy build. This is my setup. I use a Hakko FM203 with a 0.3 millimeter tip, and you want to make sure you have a vent fan. I use a silicone mat to do everything on, and I use my own Kester soldering wire, which is the same stuff that you get from Eggtimer. I just have a big spool of it. So do make sure that you use the stuff that comes from Eggtimer if you don't have your own. We're going to do an inventory of all the parts here. I always recommend that you take all the parts out of the bag, line them up, and then do an actual inventory with the checklist. Doing that really ensures not only that you have all the parts, although I've never actually had an instance where I got a package from Eggtimer where I didn't have all the parts in the package. But if there was that odd time when you didn't get one of the parts, this is where you'd catch that. I like to cut that Wi-Fi passkey out and put it to the side, because when I finish my builds, I put them in their own anti-static bags, and I like to put that passkey right in there, as well as write it onto the Wi-Fi module chip, which we'll do at the end. So put that to the side, and then let's do an inventory of all the parts. So grab your checklist and actually physically check everything off as we identify each part. So the first thing that's going to be up is the printed circuit board, the PCB, and it looks like this. So put that to the side. And then the next thing that's up on the list is the Wi-Fi module. It's pretty distinctive, easy one to see. It's the biggest component on the board. Then you have an EEPROM chip. Once again, not too. It's pretty distinctive on this build. There aren't any other 8-pin chips, so the one 8-pin chip, that's the EEPROM. You have a diode, another one that's pretty distinctive here. It has some large metal contacts on the underside of it, and it's in a plastic carrier. You have a whole bunch of resistors. You've got some 22K resistors, some 10K resistors, some 4.7K resistors, and some 1K resistors. You get one extra each of all of these. Eggtimer puts one more, just in case you drop one on the floor. They're really hard to find on a rug. So you do have one extra on each one of these resistors, should you need them. Next up, you've got some capacitors. Now, the 0.1 UF capacitors, those brown ones in the white paper carrier, that's on the right hand of the screen as you're looking at it. You need 3 of those. You're going to get one extra. It's the one on the left, the 22 UF capacitor in a clear package. You only get one of those, so don't drop it. You get some throw resistors that you're only going to need for the Wi-Fi module. You get a buzzer here, a pretty simple one, standard ferret Eggtimer, and then a bunch of headers, pin headers that we're going to have to split up and put onto the board in various places. You have one mini JST connector for a battery, for a 1S battery, LiPo battery. So we're going to put that in with the proper polarity later. You get a couple shorting jumpers for turning on the switch, and as earlier noted, you get some really high quality soldering wire that if you don't have high quality soldering wire, use the stuff that comes in the package. I use a Panavice. It's an excellent piece of equipment. Highly recommend one, not only for soldering, but for all sorts of hobby stuff on your desk. So if you don't have one of these, you're going to have to secure your board to your mat somehow. A couple tweezers, a pointy one and a flat one, I think are the easiest ones to have on hand. And we're going to start out with the EEPROM chip. So you remove the EEPROM chip, and notice that there's a small dot in one corner of the chip. That's pin 1, and that has to line up with the square on the silk screen on the board. So make sure you've got that correct. If you have it backwards, the board won't work when you're done. So just tin one of the pads. You just need a little bit of solder on there, and then you're going to heat that pad up and move the EEPROM into place. Now, the trick here is to get it centered, both left and right and up and down. You want all 8 of those pins squarely centered on those pads. Once you have that done, you're just going to go through and solder them all those pins on. Now, what you want to do here is get enough solder that it goes underneath the pin and actually solders it to the pad and gets a good connection with just a small tent of solder on top. I like to turn the board around, so you'll see the board flip around a lot in the video. You don't want a whole lot of solder. You want to make sure you don't bridge the two, any of those pins. If they bridge, you're going to have to take some desoldering ribbon or something and get all that solder off and resolder them. And the next component up we have are these capacitors. And the surface-mounted components that you're going to put on the board are all put on pretty much the same. You tin one pad and get a nice, not a huge amount of solder on there, but just enough to hold the chip and tack it in place. And then you slide your component, your chip, your capacitor in this case, into place, and then you center it both on those pads, on the metal pads on the board, perfectly, centered on those pads. Then we're going to do the other one and tack that in as well, so you can see how that goes. And then once those are tacked in and held in place, you're going to just let that cool for a second. And I like to turn the board around and make it easier for me to solder it on, but so you'll see that happen a lot but in the video. But then just solder in these each side. Now heat up the pad a little bit and heat up the side of the chip, and then once the solder flows freely, it flows up under the chip, but not enough to bridge, and then over the top of the chip, but you don't need too much, just a nice little tent. Next up are these 1K resistors, and we're going to do one in real time, same exact way as the capacitors. It's in one pad. Slide your your resistor into place. Let it cool for a second. Turn your board, and then solder each side in securely, just enough to get underneath the chip, and just solder it to the pad and a tent over there to hold it in so it doesn't fall out. From here on out, starting with these 4.7Ks, we're just going to speed it up in time. Well, I'll speed up the video a little bit so you don't have to sit here and watch in real time all of the surface mount components on this board. So get those 4.7Ks in, and then we're going to move on to these 1K. Go ahead and get the 1K in place, tack it in, and solder it in place. Next is a 22K, and we will do the same thing, tack it in place, and solder it in. Now we're watching this one. The next one up is really important to make sure you have the right one here. It's the 22 UF capacitor. It's the clear package with a red side, because it looks exactly the same as the 0.1 UF. So make sure you have the right one here. It's a little bigger, but it's very, very similar. So make sure you have the right one. Either way, it's put in the same way. Now the diode, it's important here that you notice that there's a white line on one side. So once you figure out where that white line is, you need to line it up, and you see that line is closer to one pad. Well, that's the place that the white line needs to go to. Once you've lined it up properly, it goes in the same way. You're just going to tin a pad, you're going to slide it in place and get it centered. The diode can be a little bit tougher, but just because it's a little top heavy and it wants to slide around a little bit. But once you get it tacked in, you're going to finish soldering it in just like the other surface mounted components on the board. Once we finish the diode up here, you're going to turn the board over, and there's one more 0.1 UF capacitor on the back at the top of the board. So solder that in place, and then we'll move on to the Wi-Fi module. For the Wi-Fi module, I like to use the silicon mat. You're going to take the module and the through-hole resistors that come with the kit, and functionally you're going to put the resistor wires in the holes and solder them in as pins. So just lay it out, and then what I like to do is then tape the module right to the silicon mat that I use. And this is a silicon mat that's specifically designed for soldering. I'll put a link down in the description here. And the nice thing about using this mat is you can just put the wire right into the mat. It's kind of self-healing when you pull it back out, but it sticks there nicely and it holds it in place vertically while you're trying to solder it. So I stick the first pin in through the hole and into the mat, and then I do the opposite corner with another resistor wire and solder that one in. Now functionally your Wi-Fi module is stuck to the mat. It's not going to go anywhere. You could take the tape off if you wanted to. And then just use your clippers to trim the wires about halfway down from the resistor itself, because you're going to need to do this all the way around all of the holes. So from here on out, I'll do one more in kind of real time, but just go to each successive hole, push the wire through the hole into the mat, solder it in place, and then trim it. And then we'll speed up the video here because it's pretty much the same all the way around now. But each time you do this, you want to cut the wire off about halfway, give or take, up to the resistor itself. It's really, you've got plenty of wire here. At the end, when you go to actually put this on the board, you'll find that the long wires themselves, you've got plenty to deal with. So it's not imperative that you get it exactly halfway or the same. We'll even everything out and straighten out the wires afterwards. But for now, just go around and put each wire in each hole, solder them in. You don't need a lot of solder either. At this point, you're just basically tacking in the wire. Later on, we will solder up the top of the Wi-Fi module a little bit more to make sure you have a good connection. Right now, you're just trying to get the wire to stay in place vertically. And so as you get to the end here, you're going to get to the last couple wires in. Then you're going to take the tape off and pry the module out from the mat itself. And then I find that the easiest way to straighten everything out is to take just your flat tweezers and kind of align everything perpendicular to the module itself. So kind of do it lengthwise along the module, and then go back and look at each individual pin, and you'll see that it looks pretty ugly at the beginning, but within a minute or so you can align everything properly and have fairly straight pins. And then once you get them all aligned, relatively speaking, we'll make sure we'll kind of get them in place when we go to put them onto the board itself. But then take your clippers and then just even everything out. You don't have to, once again, it doesn't have to be perfect at this point. The main intent is to just make it easier to get it into the mounting holes on the board. Do be careful when you do this. I like to put my finger over the ends of the wires because it does have a tendency to spit out little chunks of wire there that can get all over the place or get in your eyes. So just be careful when you're trimming off the ends of these wires, and control the pieces that are flying off. And that's so that at this portion, that's it. Just once again, take a look at the wires. Make sure they're straight. Don't worry about the top right now because that's pretty irrelevant at this point. We'll trim all of those off later on. So the next step here is we have to line up all of those longer pins into the holes on the board. Now make sure you're putting it in the right side. It goes into the same side that the buzzer will go on, that round circle. And the orientation is so that longer piece with no pins on it goes towards the end of the board. The easiest thing I find is just get it close and then just use a pair of tweezers to start aligning those pins up into the holes on each side. You can either push them or move them around a little bit, and then once they're aligned on one side, turn the board around and just do the same thing on the other side. And you can see here, you can just kind of give them some nudges, and you don't want to be too harsh here. You want to be just gently nudge them into the holes, and then it'll fall right into place. There you go. Now take a look at the module. It should be about 1/8 of an inch off the board. It should be flat, but not against the PCB in any place on the board. There needs to be a little space between it. Then just tape it on. Sorry, a little blurry here, but get it taped in place. We're going to turn it over and start soldering each one of those longer pins into the board. So that's what it should look like. And so get it in place. Now, starting at one end, I like to just get one pin in securely first. It takes a little effort to get this first pin going, and you'll see that they get a little loose, but just make sure a little bit of solder gets down in that hole. I mean, not too much. You don't want it to go, all bridge out into the bottom of the Wi-Fi module and connect a number of pins, but it should be a nice little cone around the pin and securely down into that hole. Now, once you get one in, you're just going to move around the entire board and get all of the pins in place. So we're going to speed up the video here, but you can see how that pin gets a little loose. If you just kind of goes straight up the pin as you're going out. It usually straightens out nicely and becomes nice and vertical. And if you don't have enough, just give it a little touch up. But you can see the gravity just kind of neatly makes a lot of the pins just get vertical in the hole. So what you don't want to do is heat it up so much that the pin actually falls through the hole. So once you get all of these done and you have a nice soldering joint with a little cone on each of the pins, we're going to turn the board over. And now you want to check these top pins out. You'll see that some of them don't have a lot of solder on them. And this is important because this is where a lot of current is moving through here. A lot of your problems will come if these solder joints on the top pads aren't good. So I like to go through and touch up each one of them. Now we're going to go trim all of the wires off here, both top and bottom. And the key here is that you want to secure that pin, the part that you're cutting off, because the wire clippers can make them kind of fly out and be a little dangerous. So, obviously wear some eye protection here and just control the cutoff portion so it doesn't fly out. And besides, the fact that it's a little bit dangerous, it can also get out somewhere else on the board. It could get underneath the Wi-Fi module itself, cause a short later on. So just make sure that you're controlling that piece, and then you have them in one place and throw them all away when you're done. So once you get them all neatly trimmed, we're pretty close to the end here. We just have a few more components to solder on. So we're going to turn the board over again, and we're going to put some headers in. Now, first thing we do is clip this set of 6 headers in half. You're going to need 3 of them on the first go around here. This is going to be where you would connect in the wire connections if you ever needed to program this or update the firmware, so on and so forth. So the short end of the pins goes into the 3 holes. Just put them in. I like to take a piece of tape and put the pins right through the tape. That makes it nice and straight and secure on the board. Turn it over and securely solder those pins, those through-hole pins, onto the other side of the board. Okay, once we get those pins in place, we have another header on the other side. This is a 1-pin header. Now this is going to be, you don't really need this if you're never going to hook it up to a telemetry module, but if you do plan to, I primarily use these altimeters for to connect to telemetry modules. We can talk about that in another video, but you're going to need this 3-volt pin in place. So just tape that in and solder that securely on the other side of the board. Okay, once we've got the header pin soldered in, the next thing up is the buzzer. Now the buzzer is polarized. The longer pin is the positive terminal. So you want to make sure that that longer pin goes into the hole with the plus sign. Once you've got that, and that's really the only key thing about this buzzer. It just simply drops into the holes, tape it in place, and then you're just going to turn it over and solder those pins. So pretty simple one here. Once you've got those soldered in, you will want to trim off the short pin. Is just fine. It stays in place, no problem. Or it's not that far off the board. It's not standing that proud. But the long pin does stand pretty proud of the board. So once you get those soldered in nicely, go ahead and trim off that longer piece of pin, again securing that cutoff piece. Now, we're going to talk about the battery a little bit. Batteries are important here. You have to know which kind of battery you're choosing. In this particular case, this is a kind of a hobbyist battery from SparkFun, and they have the terminal, the negative side on a particular orientation, and you have to know which one you're going to use for your build. If you use a remote control, one that goes for like a helicopter or one of those remote control units, they might be reversed polarity. So put the connector of the battery you're going to use into the actual JST connector, and then mark the right side, the correct side, with the negative terminal. That way you can't mess this up. But you definitely want to check it against the 1S battery that you're going to use. Once you know that, just put it in place so that side you marked is on the negative side of the board. Tape it in place and then solder that in. Once that's soldered in, there's only one more component we have to solder in before we can test the board and see if it works. And that is kind of the decision you're going to have to make on this next component is how you're going to switch the unit on and off. I like to use this switch like it shows in the instructions, just using a terminal headers here and a jumper, mainly because I'm generally using this board as a telemetry module companion. So usually I'm putting this in something that's modular that I'm going to be able to switch from rocket to rocket, and I'm going to keep this on pretty much all day. So I don't mind just putting a jumper switch on here at the beginning of the day and using it for most of the launch day. So once that's in place, it's pretty much complete. This is what it looks like when it's done. And now we're going to test this out and see if we soldered everything correctly. So take your battery, and since I used the terminal block or use that header block for switches, nothing's going to happen when I turn the battery on or plug the battery in, which is fine. And when I put the jumper on, it should turn on and beep. Okay, we've got proper beeping. It's going to beep through whatever the last altitude is, and it's going to go through a number of beeps. So we can say right now that we've probably done a good build. Now, what it should go to is a series of rapid chirping if we've done it correctly. So once we get to that rapid chirping, we know that the build is probably pretty good and we can connect to Wi-Fi. All right, there we go. Now, while this is happening, I connected to the Wi-Fi chip on my phone, and I brought up the Eggtimer page in my browser. And now that once you have that done and you're connected into the altimeter, you know you've got a good build, and this is what the screen looks like. And so it's armed right now, obviously, because you just turned it on. And if you want to just turn it off, just put the code in and hit disarm. There we go. All right, and the last thing I like to do is put write the actual number for the wireless key onto the chip itself, onto the Wi-Fi module. That way, if I ever lose the paper, or I install this a couple years down the road, it's right there on the module, and I don't have to worry about going to look for it in the future. So that's it. That's the build. It's a pretty cool module. I'll do another video where we talk about how you can link this into a telemetry module and make a modular kind of unit out of it that you can switch from rocket to rocket and get cool data throughout the entire flight. But this is a great build. I hope that you have a good build as well. And if you have any questions, post them down below. Thanks a lot. Bye.